All right, we're going to be taking a look at 3.5, working with parallel and perpendicular lines. So today we're going to examine parallel and perpendicular lines so that we can identify them, so that you can identify them by yourselves. You'll be able to look at an equation and say, oh, those are parallel or perpendicular lines. You'll also be able to identify them in a graph. You can look at a graph and say, oh, those lines are parallel, those lines are perpendicular. You'll know you can do it when you can tell if the lines are parallel or perpendicular from an equation or a graph. So that's kind of where we're landing today. So what are parallel lines? Parallel lines are lines that never cross. They have the same slope and they have different y-intercepts. So they never cross. So on a graph, we're going to look for lines that never cross. They would run side by side with each other. They run side by side with each other because they have the same slope. And this is important for when we're looking at an equation. We'll be looking for the same slope. And they need to have different y-intercepts. That means that they cross the y-axis at different places. If they have the same y-intercept, then it's just two of the same line on top of each other. So it's not a parallel line, that's just the same line written twice. Okay, perpendicular lines are two lines that cross at a 90-degree angle. And they have opposite reciprocal slopes. So the opposite being the opposite sign, and reciprocal meaning that it's flipped over. So if it's a fraction of 1 over 4, the reciprocal would be 4 over 1. If the slope is 2, the reciprocal would be 1 over 2. So the opposite reciprocal means we take the opposite sign and we flip it over. So let's take a look here at some parallel lines in equations. So when we're looking at two equations, the most important thing for identifying parallel lines is that the equations themselves have to be written in slope-intercept form. If these are not in slope-intercept form, that's y equals mx plus b. If these are not written in slope-intercept form, we can't tell right away, and we have to manipulate the equation to get y by itself so that we can tell what the slope is. Once we have that, like we do in example A, we look at the m value. So our m value is the value that's next to x. So in my first equation, m equals 2 over 5. And in my second equation, m equals 2 over 5. And because of that, these are parallel lines. We also want to just double check to make sure that our b values are different as well. So b equals -3 and b equals 7, just to make sure that they're not the same exact line. Okay, so again, parallel lines, if we're given two equations, all we have to do, we have to look at the m. We're comparing the m's, the slopes, in each equation. Those check out, and then we're also just double checking that our b's are different, and those are different. So we're good. So these are parallel lines. Okay? In fact, all of these examples are parallel lines, all four of these. So look how simple it is. These are the same, and our b's that I just circled are different. So I boxed our slopes are the same. So those are the same, which is good. And our b's are different. If our b's were the same, then we would just have the same line written twice. It wouldn't do any good. Okay? So again, just our last one. If we are given something like -x or +x, and we're looking here, the slope here is 1, the slope here is 1, and our b values or our y-intercepts are different. So that's what parallel lines look like in an equation. They have the same slope. Let's talk about parallel lines in a graph, and I'm just going to go ahead and graph these. I'll color coordinate them, so I'm going to color coordinate. My first line will be red, my second line I'll graph in blue. So in red for my first line, b tells me where to begin, so I'm beginning at -3, and I'm counting up to right 5. I could also go down to, it would help if I actually went 2 though. I can also go down to left 5. No. If I hold my pen down, it'll make a straight line. There we go. Okay, in blue, I'm beginning at 7, which I don't have enough graph here because I didn't think that one through, I guess. So 5, 6, 7 would be somewhere up here. You know what? For the sake of this, I forgot to change it. I made the equation before I made the graph. So let's use just anything. Let's use 1. Let's just say plus 1. 7 would have worked, but I don't have enough graph. So if I begin at 1 and I count up to over 5 and down to left 5, what you should notice is that my lines rise and run exactly the same. So here's my if my y-intercept was 7, my line would be like up here. Here's a y-intercept of 1. So the y-intercept just changes, you know, where it is. There's a y-intercept of -1, a y-intercept of -2. And what you notice is it doesn't matter where the line is on the graph. It's never going to cross my red equation because the slopes are the same. So that's parallel lines in a graph. I'm just going to do example C. So again, I'll do a red equation, a blue equation. I'll do my second equation in blue, my first equation in red, just so that you can see the difference, okay? So we begin at -1, and we count down 1, right 2, down 1, right 2. Oh. You can also go up 1, left 2. You can do the exact opposite. And create my line. And then for my blue equation, I'm beginning at +1 and moving down 1, right 2, down 1, right 2, or up 1, left 2, up 1, left 2. So you're seeing I went up 1, left 2, up 1, left 2. I can also go down and right, down and right. Now these lines probably aren't going to look perfectly parallel because I didn't use a ruler, but they are parallel. So they are in step with each other in such a way where they would never cross. So there are parallel lines. So we can tell on a graph, if we were just given a graph like this, you could tell they're parallel lines, one by looking at them that they don't cross, but we can really make sure by going in and counting the slope. So the slope of my blue line, I rise -1, run 2. The slope of my red line, doesn't matter where, 2 points, I rise -1, run 2. Let's talk about perpendicular lines. Perpendicular lines in an equation have the opposite reciprocal slope. So E, F, G, and H all have examples of perpendicular lines. Again, we are just looking at the slope here. And for these, when we have a slope of -5/2, the opposite reciprocal means it's going to need to be positive. That's the opposite. And flipped. It needs to be, for this one, it needs to be positive and flipped. So we're going to check that over here. We have positive, so that checks out. So it's positive, and it's flipped over. So we have 2/5. So these would be perpendicular lines. We can tell from the equation by looking at the slope. They need to be the opposite sign and flipped. So again, in F we have 1/4. So over here, I need to have the opposite sign, so it needs to be negative. and I need to have a flipped, or the reciprocal. And the reciprocal of 1 over 4 is 4. If you needed to write it, you could write it as 4 over 1 to see it. So perpendicular lines, again, we're looking, here's positive 2. So the perpendicular of positive 2 is negative 1 over 2. It's the opposite sign and the reciprocal. And we can do it backwards too. So the reciprocal of negative x, if we look over here, this needs to be positive. And the trick with this one is negative 1 over 1. And the reciprocal of that, if we flip it, it needs to be positive, right? But the 1 over 1, if we flip 1 over 1, is still 1 over 1, which is why I wanted to use that example. Okay? So let's talk about what it looks like on a graph. And again, instead of 7, because I didn't think forward on this one, we are going to use 2. We'll just use 2. Okay, so I'll graph my first equation. We have negative 3 is where we begin, and then I'm counting down 5, right 2. I don't have enough room to do that, so I'm going to go up 5. 1, 2, 3, 4, 5. And left 2, and left 2, 1, 2. And get a line like that. Again, on the iPad, I don't have a ruler, and so it's kind of hard to create exact lines. My points are right, my line is not great, but that's how it goes. And then in blue, I'm going to begin at 2, and I'm going to count up 2, right 1, 2, 3, 4, 5. I could also go down 2 and left 1, 2, 3, 4, 5. And when I graph my line, what you'll notice, and again, it's slightly off because of I'm not using a ruler, but I want to bring your attention right here. It creates 4 right angles, or it should create 4 right angles. So there's a right angle, there's a right angle, there's a right angle, there's a right angle. Okay? So perpendicular lines will create right angles where they cross. And that always happens when we have the opposite reciprocal for the old slope there. So I'll graph my first equation in red, beginning at 5. I can't move up and right, so I'm going to move down and left 4. And gosh, I really didn't think through this. I think I was so focused on the opposite reciprocal, I didn't think about b values that would allow us to work on the graph. So if we were to begin at 6, which would be right there, and then we would count down 4, 1, 2, 3, 4, right 1, and create our line. So something like that. What you notice is it does create 4 right angles. Okay, one more example. I'll just graph this one really quick. So my first equation I'm going to do in red. I begin at -1, and I count up to right 1. Can also move down to left 1. Create my line. In blue, +1, and I can move down 1, right 2. Somewhere there. And these create my right angles. So perpendicular lines. They happen when we have the opposite reciprocal slope. Okay, last thing, we're going to talk about parallel, perpendicular, or neither. And here's what I'm going to do for this example. I have one equation that I am going to compare my other 2 equations to. So in red here, This is the equation that's kind of I'm going to compare these two equations to it. So I have y equals 2x plus 3, and I'm looking for, is it parallel, perpendicular, or neither? And I do believe that I blew right past other lines. So we talked about parallel lines. We talked about perpendicular lines. So parallel lines have the same slope and different y-intercepts. Perpendicular lines cross at a 90-degree angle, and they have opposite reciprocal slopes. All other lines, so two lines that are not parallel or perpendicular, will just cross at one point eventually. And we're going to be working with those kinds of lines in our next unit. So that's what it means when it's neither. They don't have the same slope, or they don't have opposite reciprocal slopes. So the deal with this is that in order to check the slopes, my equation needs to be in y-intercept or in slope-intercept form. So I am going to solve this right now to get y by itself. In order to get y by itself, I'm going to move my 4x to both sides first. Now I can't put 4x and 10 together because they're not like terms. So I'm going to leave them separate. 2y equals 4x plus 10. And then to get y by itself, I need to divide 2. When I divide 2, I have to do it to every term. So I'm canceling that out, and I'm left with y equals 4 divided by 2 is 2x plus 5. Now that I have changed my my equation into slope-intercept form, I can compare my slope here and here and find that these are parallel lines. Okay, so that one's parallel. For my other equation, again, the way that I can compare them is I have to get y by itself. So I'm going to do that by subtracting x to both sides first. I get 2y equals negative x minus 6. I can't put them together because they're not like terms. And then to get y by itself, I need to divide 2 to everything. And that gives me y equals negative 1 over 2x minus 3. So now this, that negative 1 over 2 is what I'm comparing to my original equation. And I'm looking for, is it the opposite? So it is. It's the opposite sign. And is it the reciprocal? And it is. So this is a perpendicular line. So just wanted you to be aware that we may need to manipulate equations before we can compare them. Okay? And then the last thing I want to do is talk about finding a parallel line and a perpendicular line when given instructions. So parallel to y equals 3x plus 4 and goes through negative 2 comma 6. So you'll see problems like this where it says find the equation of a line that is parallel to this line, but it goes through this point. And there's two pieces of information we need in order to write the equation of a line. I'm going to write them in purple here. We need to know our slope, and we need to know our y-intercept. If we can figure out those two things, then we can write the equation of the line. So here's how we're going to find our slope and our y-intercept. So our slope for a parallel line has to be the same. So our m has to be 3. Great. Well, how are we going to figure out our b? We could use point-slope form. We have a point, and we have a slope, so we could absolutely use point-slope form. In fact, I'm going to, just so that you can see it. The other way would be to plug in into slope-intercept form and solve for b. But I'm just going to use point-slope form. I have a point. I have x and y. I'll call them x1, y1, and I have my m. So point-slope form is y minus y1 equals m times x minus x1. So I can work this out double negatives on the inside sandwiched together become a positive, whether that's slash and dash, however you do that. It is now, I'm working with x plus 2. I'm going to distribute 3 times x to get 3x, 3 times positive 2 to get positive 6. Y minus 6 equals 3x plus 6. I need to get y by itself, so I'm going to add 6 to both sides. And y equals 3x plus 12. So this is the equation of a line. So my b ended up being 12. I used point slope form. The other way would have been to have taken y equals mx plus b and replaced it with the info that we had. So y was 6 equals 3 times negative 2 plus b, and then work it out. 3 times negative 2 is 6 plus b, and then we would have to, sorry, that's negative 6, so then we would have to add 6 to both sides, so that 12 equals b, and that is what we found in our other equation. Then we would just plug in our m and our b. Let's talk about perpendicular. So if it's parallel, the slope, you just use the same slope. But if we're looking for perpendicular, perpendicular means we have to use the opposite reciprocal slope of what we've been given. So if that's a positive 5, I need to use a negative. And if it's a 5 over 1, I need to use 1 over 5. And then again, I could either use point slope form, or I can use y equals mx plus b. I'll do the other way just so that you see it. So here I have an x and a y. So I'm going to say y, that's my y value, equals m, which is negative 1 over 5, times x, which is 10, plus b. That's what we're trying to find. We don't know that yet. So I'm going to multiply 1 over 5 times 10. These cancel out to give me 2. So negative 1 times 2 is negative 2. And then I'm adding 2 to both sides. And negative 2 plus 2 is 0. So 0 equals b. So what that means, b can equal 0, is that the perpendicular line, or the line that's perpendicular to y equals 5x minus 3, that goes through the point 10, negative 2, is going to be y equals my m, which was negative 1 over 5, times x, plus b, which is 0. So I could write it like that. That's a fine answer, but 0 doesn't really need to be there.